Hello, permutations. Given an array nums of distinct integers, return all the possible permutations. You can return the answer in any order. Very similar to the last question I did in the videos. Uh, it was subsets. Yes. So we have an array of no array. Just have to return all the combinations of the numbers of the array. 1 3 2 2 1 3 2 3 1 3 1 2 permutations. It is a rearrangement of all the elements in the array. So we have 1 2 3. All right. Backtracking problem. Taking this array. We will in our result array, first of all, when we get there, we will append this entire array, and then we'll remove yeah, the size should be 3. Size should be each subarray's size should be equal to the size of the input array. That this can be a useful condition. Void permutate we will have our input array, our temporary array, temporary list, well, temporary list of integer, temporary, and we'll say that if temp's size is equal to the size of input dot length, then we want to add this temporary list to our main result list. Temporary list. Should I do this way? I'm very confused about temp. Is this the right way to do it, or just simply this? Yeah, I will look into this later. Yeah, this function will also accept a list of list, which is going to be our result list. Result, and I think a starting variable. List integer result, new array list. Permutate nums, new array list, result, and some sort of starting index that we need to decide on. Finally, we'll return the result. Okay, now we have to define our loop. Is where our backtracking step would happen. So I'm gonna say 1 2 3, 1 2 2. Duplicates are not allowed, so it's gonna be 1 3 2. Okay, so each time array should start from 0, from the first element. So I can say that I is 0, I is smaller than inputs dot length whatever, and plus my keep incrementing my I. Now for adding this into our temporary list, well, we will do some step here. We don't know that yet, we don't need to know that yet, and we will run a recursion here, and once the control gets back in this block, once it leaves the recursion, we want to do our backtrack step. That is that will remove the last element from a temporary array, right? Temporary list. And I think after we did this, we need to return from here. Yeah, we need to break out of that. Okay, 0. If I passed in 0 as a starting point, so temp dot remove element at the last index. So that's easy. Size -1. Okay. Now for the logic for adding the number, right? All the integers of the norm are unique. Yeah, so there is not going to be a duplicate in the inputs. Okay, if we have 0 and 1, 0 and 1, and 1 and 0, so 0 1 will then remove the 1. Yeah, let's start with start 0. We want to say well, once we have made sure that the size of the list is less than the input, we can temporary dot add input I at index I. Let's pass in arguments. Input temporary result and main thing. If we don't increment I, if we just send an I, it will start from 0 again. We don't want that because it would cause duplicate then. Well, let's try I plus 1. Okay, so for this we are adding 0 to a temporary list, and then we are doing the recursion step. We are coming back here, checking, okay, if the size of the, it's not, then here. Now the value of I would be, because it was I plus 1, it would be 1. And temporary list, adding that element to temporary list, 1. Coming back here, now this will run, and there is a temporary list getting added to our main list. Okay, now there is a return, so we're coming back here. This was a second recursion call. We have one more call in our call stack below this. Okay, this returned nothing, returned void, and then this step will execute, which removes the last element from the list, which was 1. So now we only have 0 in the list, in a temporary list. But there is because no, the loop will not run because I was 1 already, because we are in the second call, second recursion. I was 1, and so yeah, it would this condition would cause the loop to break. Then we'll come here, and we will at the same time come out of the first recursion call. That will remove this. Now there is no element left in the temporary list, but there is one more cycle of this loop left, which will, now the temporary list is empty. In the next cycle of this loop, we are adding 1 in the loop, right, and 1. Okay, and at this point I is 1. But if we alright, so this will not work here because I is already 1, and if we passed in, now the I will become 0. It will not even enter in this loop. Fair enough. Because we want 0. I just wanna see the progress so far. Okay, all right. I think this is the right way to do it. Okay, see, yeah, only one element is getting appended. Understand? Just as we uh, dry run in our heads. Okay, so now if I make I if I make it run from 0 every time, um, it might cause some duplicates in my, okay, let's do that same thing again. Okay, we for the very first time we are here adding 0 to the temporary list. Recursion step, we come back here, check this condition, no, we come back here, then we enter the loop again, starting from the 0 again. So without checking anything, we just add 0 to the temporary list again. This is what we want to avoid. Can we check, okay, if that element is already in the list? Because if we can, then it would just like be the okay. So if this is a list, when one is when we only have one in the final list, at this point it can well, it would take 2 recursion calls to make this combination and this combination. Notice how well, we just have to make sure that I is not equal to start. Let's do it again. 0 is added, then we come here, the next it's now starting from 0 again. Because of this condition, 0 will not get added. This, since this was already a recursion step, no, if we want to continue, right? Continue. Yup. then you add 1, then you send 0. Then here at this step, this condition matches, boom, we have 0 1 in the final list. We return from the second recursion call, and the last element gets removed. At this point, the value of I is 1, or we are 1. So value of I is 1. Okay, so last element, which was 1, gets removed. We do not have any more iteration left in this call, so we exit. Now the control is back to the preview call. This is so hard when you do it in your mind. The control goes back to the previous call. It was at the I was 1, the I was 0, the I was 0. But if we did that, because okay, we were starting from the 0 anyway, and the I would be 0. If we did this step, we won't even have a 0 in getting added into our list. Yeah, this is not the right way. We need an extra condition somewhere here, because that thing would have prevented even 0 getting added in the list. Element had 0th index. Okay. Well, what do we want to say? I wonder, can't we do the backtracking step here? Like, what if we do not return at all? But that won't work. And yeah, of course, that won't work. Okay, let's send the element itself to the instead of sending the index. Let's pass send the element itself between the calls. Well, if we had 0, if we have a 0 as a argument, we will simply add this to our temporary list without any questions, and then we would if the list is smaller than the, well, I'm thinking of removing this return. Uh-huh. Not at all like the last problem. Uh, subsets. Yeah, subset was way easier. This also seems easy. I'm just stumbling around, I guess. Yeah, but yeah, I have 4 more minutes. I can't like spend 50 minutes on every problem. Okay, just have to just find a way in 4 minutes. Well, let's see. Well, I don't like we are doing this, right? So I'm gonna say that whatever well, if start is smaller than the in dot length, then we just temp dot add input dot start. Now let's look at the repercussions. It's just so easy to write something abruptly and then okay, so if it's 0, then that means okay, if it's less than we are adding anything that's coming in. Okay, so for this loop, because I think we're gonna have to start it from 1 now. From 1. One, we permutate, we add, because we add, well, I is set to 0 again. Now it's 1, right? So 1 will be added to the temporary list. We go back, we enter this loop from 1 again for some reason. 0. Well, 0 plus 1, if you don't like that. 0 plus 1. Okay. Okay. Then what's the point of even stack overflow? Temporary dot add temporary. But why is stack getting overflowed? Okay, we failed. So it's permutations. All right, we weren't supposed to return from there. See, my little guess was right. Yeah. Okay, let's now we got a little hint. I think we'll be able to do it on our own. Uh, no, not returning from here. Yeah, zero, and we just check. Okay, this question actually builds on top of the subset question. Essentially, the step is same. If temps dot contains, if it doesn't contain input I, then add it. Still, but okay, so if we where are we returning from then? Okay, wait, oh, let's see. Okay, continue. Temp dot add input dot I. Okay, fine. What I learned from this is that you don't blindly put returns. Yeah, we did not need a start. We did not need what else? Yeah, we did not need to return from once the list, once this condition matches. So let's try run now. Okay, so the 0 1. Okay, we are here. Okay, 0, it's a 0 getting added, 0 getting added to the list. Permutate, this is false. Enter the loop again from 0. So it is at this index we have 0. We continue next iteration. I is 1, which is 1. Add that to our list. Permutate, this condition matches. Okay, may results get something. Okay, we don't, I mean, we'll just put, yeah, right, let's say if I do something like this. return C. Okay, we were pretty clear. We were pretty close. Only this step. I think I even tried something similar. Oh, okay. But yeah, I was very confused. I started playing around with this I, which we did not even need. So yeah, I got confused with this I, but yeah, the rest was pretty simple. This I by mean I meant to start. This start variable, call, argument, whatever you call. Okay. Task scheduler. You're given an array of CPU tasks, each labeled with a letter from A to Z and a number n. Each CPU, we are given an array of CPU tasks, A to Z and a number n. Each CPU interval can be idle or allow the computation of one task. Okay, each CPU interval. Tasks can be completed in any order, but there's a constraint. There has to be a gap of at least n intervals between two tasks with the same label. There has to be a gap. Oh, all right. There has to be a gap. But tasks can be completed in any order, but there has to be a gap of at least between same. Okay, so between these two, A, there has to be a gap of two intervals. Return the minimum number of CPU intervals required to complete all tasks. I think I need to turn off the camera. I can't. I'm like very under the weather right now. So yeah, let's just do it without camera or mic. Oh yeah, let's just. I don't care. B. So minimum number of CPUs. Minimum number of CPU intervals. 8. A possible sequence is A B. We did A. Now to do A again, we have to wait for two intervals. This two. So B. So we did a B thing, and then we did not do anything for one interval, and then we did A again. What kind of problem is this? I know I remember watching some kind of solution, but I have forgotten everything. What's the topic? Hash map, greedy sorting, heap counting. Okay. Oh, it's a heap. I think it's a heap problem, right? We need to keep a min max heap. Is that it? I also remember coming across a solution which like pre-calculated the position uh, of each task in a way that we had empty spots. No, I don't remember. Counting. Okay, so counting is one of the ways which I'm not gonna do. I'm not good with math. Hash table, greedy, sorting. Why is sorting? Oh, so we can so we can know how many similar tasks we have. Right. A is A, BDB. Yeah. Here we can do A, and then we can do C. We can do B. That's 3 intervals. Then we can do A again. We can do D, and then we can do B again. Okay, the N was 1. Okay, so we yeah, we can complete each task in one interval. So that's like the minimum. Is it to like the minimum, the length of the tasks in the array could be the minimum. One, two, three. Okay, so I think the size of this array is going to be the minimum uh, minimum amount minimum number of intervals it's gonna take anyway. It, and after that we start looking into the idle points and uh the okay, maybe not. Here n is 3, so between similar tasks we have to wait 3 intervals. We can run A, but we can run B, right? But we can't run A or B for another 2 intervals. Should I try to simulate this? Is simulation? There are many different solutions for this problem, including greedy algorithm. Most frequent array hash map. Okay, so I create a hash map of the frequency of these tasks, and then I keep okay, let's do that. Let's start from there. At least we got a starting character integer map, new map, hash map. Okay, for character task in tasks map dot put task map dot get or default to map dot get tasks, and if it's not there, then just return a default value of 1. That just return a default value of 1 or 0 0 0 or 1 0, right? Because we are incrementing it anyway to 1. Alright, let's just quickly make sure the map is built correctly. Not 0. Yep. Now I need some sort of a loop. Okay. For every cycle, find the most. For every cycle, we need that can be placed in this circle. That can be done in this circle. Okay. After placing, decrease the frequency of that letter by 1. Got it. We need a variable and interval initially set to 0. While loop, some kind of condition. I don't know, let's say while hash map is while hash map's size is greater than 0, and at the end of each cycle I want to increment my interval, and I want to return this interval at the end. So okay, now I gotta keep track of this this state of this n. Okay. Okay, let's see what all tasks. Maybe last performed task or last task. Okay, it's gonna be a list. I'm thinking of maintaining a list of the tasks that are still in the memory. That means that we can't perform until some sort of counter becomes 0. When that counter becomes 0 for each task, okay, But for that, I could have I could have had a uh, I could have had a pair of something like this, so where on the left it would have the task, and on the right it would tell me for how many more intervals I have to wait until I can do this again. But no, that would be very complicated. uh, um, how do I maintain? I have to keep track of this internal state. Keep track of each task's interval. Would so even if I do nothing and just try to simulate this problem. So we are at A. We mark A as last performed task. So now we can't perform another A. We can't perform this A too. So we can perform B, but now we've just performed B. And by the time we got here, okay, it has to happen in the same. After we perform the task, interval increases, not at the end of the loop. Okay. So I can say while let's keep a let's keep a some kind of k here. While, which will go look for tasks in our in the hash map, basically map. While this task what if we keep a stack? What if we keep a stack? Use priority queue. Just use priority queue. I right. Well, if we had a priority queue, we could do something like this. Okay, you know, yeah, it would be easier to check the frequency with priority queue. Tasks with the highest frequency get moved uh, on the top. So so what? A queue of what? Queue of pairs or a queue of hash? Would hash map do the same thing for us? Yeah, but with the queue we can avoid the looking for the most frequent element, but that's an optimization, right? We can just we can do the same thing with hash map as well, with this while loop, while the rest of the code stays same. So yeah, I think the priority queue is only for the optimization. So I'm just gonna keep uh, just gonna continue with my approach. Well, I was thinking of keeping a stack for recently performed tasks. Okay, so we put A onto a stack, meaning that we did A, and then but no, no. Interval. Somehow, somehow, somehow. Idle. Q is first in, first out. If we have a if we keep a queue, normal queue, and we add A to it, and then we add B to it, indicating these two are the these two tasks have been performed in less than an interval, like very recently. And as this interval increases, when our interval becomes n, then we pop off. But yeah, that's the same thing. That's like maintaining uh, a separate interval for each task. Like going back to the pair solution with pair. Uh, I don't like this. I don't like this. All right. What if could be of could be one of the possible way. Like we maintain an array. Uh, we map a task to its frequency and its interval clock. So that would, if map.get tasks is an error, say if either way it's fine. A map dot contains doesn't contain task, the map dot put task and a new array. What? A. Well, now I'm thinking of maintaining two hash maps. So one for the yep, two hash maps. One for the one for keeping track of frequency, another for keeping track of intervals. Keeping track of intervals. For map dot for character map dot get keys or keys only, I don't know. Or task get keys, another hash map. All right, which will it's a map of task interval tasks interval dot put task task interval dot get or default zero task 0 plus no, no, there is no default. No, only put n. So I can say tasks, right? Something like if map if task interval dot get task. Nah. No. I get the feeling it would not work. Like it needs proper planning, guy. Uh, okay. Okay. I think it's time to look at the solution. Do we 30 November? Well over 15 days. Okay. Not maintaining a hashback. Okay. Storing ASCII values. No, storing okay. I got it. Zero. I think this is a well-made pattern now. I think this is some sort of a pattern. The question has some alphabets as inputs. I think uh, yeah, I will keep that in mind next time. Okay, min-max. Alright, this is min-max equation. Okay. We basically okay. We don't even care about the alphabets. Uh, we only care about the frequencies, right? It's not like we have to return the the sequence in which the tasks are performed. So we got rid of that in the step 1. Only maintaining frequencies. Next, we are keeping a priority queue. Okay, we're checking all the alphabets, adding that frequency to the priority queue. We are simulating. Each cycle consists of some tasks. Okay, some tasks fill the current cycle. If cycle is greater than 0 and this queue is not empty, cycle minus cycle minus. So cycle, if n was 3, if n was 2, the cycle is 3 while cycle is greater than 0. Greater than 0. Okay, this loop will run for n times basically. Okay. Frequencies, getting the maximum frequency here, checking if it's okay, if checking if the frequency is greater than 1. Why do we need to check that? The frequency of tasks still needs to be executed. we are adding it to some kind of list. Where is that list? And it's not add. Where is that list? PQ. What's ls? This list, or okay. Here we decrease the frequency, added the new frequency to the list, and task plus plus. Task was 0, now task is 1. What is task? Why are we incrementing task? Again, we are not putting back anything in the queue. We're not putting anything back to the queue. Okay, we are here. Task for I re-add remaining tasks to the heap. I. Okay, the tasks which we in this cycle which we added to this in this cycle, adding them back to the queue. Again, we'll check the most frequency here. The task with most frequency will get executed until this cycle. Okay, which is essentially m. At the end, this task is just keeping track of how many tasks we have executed. Increment time plus, if this queue is empty, then task, or n plus 1. If the heap is empty, add only the executed tasks as a full cycle each time. Well, if this entire code took only one iteration, that means the task was already arranged in a way that there wasn't any idle time between them. So in that case, the thing would get added to this list and this will not run. We will just increment our time with tasks, meaning that the final result is just the size of the array. I think this is how this is working. Okay, I have to try it once more. Gonna put it back to empty. Yep, that was the video. Thanks for watching.